Nice job.
Push it out first. You can do one more. Why am I shaking so much? Should hold your hand with this. Yep. That's okay. It's crazy. It's free.
Oh, I probably collected it. Okay. You guys all? So at this point, you can, put your glasses up on your head. You don't need the gloves on, so you can actually take them up and throw them away over here behind Sharon. Okay. So I'm going to, you guys can either sit there or gather around. But what I'm going to do now is plug in the three chambers into this power unit. Always making sure red is going to red and black is going to black.
Which one was ours?
Do you remember what table?
That one.
So that's why I labeled them.
Good idea.
Because they all look the same now, okay? So 1, 2, and 3. And then this unit is plugged in to electricity, the outlet, and then of course to the chamber. There's a little wire at the bottom of each end, and what you'll see when I turn the unit on, little bubbles will start to go, and that tells you that the electricity is running. What happens is from the negative end to the positive pole, electricity is running through the liquid that's in here. So if we were to touch it, we would get electrocuted, which is why the lid is there. And then we're not going to have it at the table. Okay? The electricity will run from this direction down, so to the positive end. DNA, the molecule, is negatively charged. And what do we know about charged particles? Negative and positive opposite charges attract one another, right? So the negative DNA is going to be pulled down towards the positive end, okay? And we're about to learn, what's happening as it's moving. Okay, that's going to be with those legs. So I'm going to turn on the unit, and I'm going to put it to 200 volts.
What's this?
That's going to be our light box that we use to look at the gel. once you've seen the fizz, go back to your tables. And this will run for 20 minutes. We'll give it 20 minutes, see what happens.
I'm happy. Hey, are you going to the grocery store? I don't do this.
Better be. Oh yeah.
Why? Maybe I don't. Oh, I see the fizz.
Okay. Okay, this one had the wells. As we run current from the top of the gel through towards the bottom, remember it's running from the negative pole to the positive pole, and the DNA is being pulled. The DNA that was in, say this was the sample that you have was like, you guys had the victim, and you guys had evidence, and you had suspect 1, and that one way over there is suspect 2. So this is our lane, 1, 2, 3, 4. Okay, and then 5 and 6 over in the back. Okay, so this is lane, and this is how the bands of DNA of those different sizes separated out. The bigger the molecule, the slower it travels through the gel. The gel is actually, even though it feels solid to us, if we were able to look at it with like a super powerful microscope, you would see that there's actually holes in the gel. And those DNA can go through the holes like a shoelace, through the eyes of the shoe, the eyelash. But the longer it is, it takes the longer DNA molecules, the longer time to get through all those holes. It's a lot to do. Whereas the short ones just go zipping through all those holes. Okay? So in the same amount of time, we're going to run our gel for 20 minutes. In the same amount of time, the longer fragments are only going to travel a little bit, and the tiny fragments are going to go much faster. And so it works like a colander. Okay? Things are being separated now by size. I actually have 2 columns of DNA sizes. Your DNA here and your DNA here, facing along like this. So like this one looks like the smallest one that should go here. Okay, so the longest one is towards the wide end of the table, the shortest. Yeah, so I want tell you, we have to stain it. The DNA, the only blue that you see right now is the it's called loading dye. And that's so that you can track how far your sample has gone.
What is that?
The blue is very, very tiny. Okay, so it travels the fastest. So I know that somewhere between this blue line and the wells is the DNA. Okay, I know that it hasn't run off because of the blue line is still here. Okay, so actually on this shaker bath, on this silver shaker bath. Okay, and a lot of, can you guys, here I'll walk around with it. So a lot of it's coming out. Okay. You think that's been 10 seconds?
Yes.
Okay.
No, just leave them there.
So here's the one.
Thanks.
And I'm going to put it in, it needs to destain some more. See how there's a lot of blue that got stuck in the gel itself. So we need to rinse all that excess out. And we're going to do that by telling it to start.
Well, it works.
It didn't look that fast when it didn't have any water in it. Yeah, maybe, well, you guys have
I'll mess with it.
evidence because my DNA traveled further, which means it was shorter. This one traveled less, and this one traveled the same distance. So you can say that they are the same. Now what DNA, this kind of DNA fingerprint does, it just tells you the sizes are the same. It doesn't tell you that the sequence is the same. So really, like if you were in a court of law and they were using restriction length evidence, I would have your lawyer challenge that.
Because it's not as definitive.
Because like, you think about it, your socks are the same size, but one is blue and one is black. So they're the same size.
Lawyer is
is got
Right.
this all figured out. That's his defense.
Who?
Richard, your youngest.
Oh,
brother.
yeah. No, he's an accountant. He wouldn't know all this stuff. So